Now let us go ahead and take on this extra question which is not there in the worksheet. Now it is an example where you are supposed to calculate the expected return and also calculate the portfolio variance using the Markowitz model, and also calculate the portfolio return and the portfolio risk of variance using the Sharpe's single index model. Now let us go ahead and take on this question. Yes, ma'am.
The following question related to the Sharpe and Markowitz methodology. The following data on 4 stocks are given below. Stock A, should I read stock?
Only for stock A. Stock A, what is given?
Stock A, Markowitz expected return is given at 17%.
It is 17% is supposed to be the forecast return.
And the alpha value is minus 0.06.
And then the alpha value, this alpha is not the Jensen's alpha you think. This alpha is supposed to be the constant that is calculated for the purpose of the single index model. Is that fine? Next.
Then unsystematic and systematic variance is given, which is systematic 5 and unsystematic 4.
But remember, these are not a percentage, these are percentage square. They are given the systematic and unsystematic risk of the stock in terms of variance, 5 and
4.
And 4.
Then correlation matrix is given.
Now they given this data for even for stocks B, C and D. And then is given the correlation matrix. That is given the correlation between A
and B.
See, A and A has to be 1. That can't change. But A and B, they given 0.4.
A and C 0.7.
Like that.
A and D 0.2.
Okay. And so on for, BC and BD. And also for CD. Yeah. Is that fine? Yes. Next.
Next, the market and stocks correlation.
Basically given the correlation between the return on the stock on that particular security with the market. Next.
For A, it is 0.74.
Okay, for example, 0.74.
Then, for example, the correlation of returns between B and C is 0.6. Between B and market is 0.5.
And the examiner has been very, very kind. You got to bless the examiner's cotton socks. Because the examiner has explained how to read the table, matrix. Right? The matrix. Next.
Number 1, Markowitz would argue that a portfolio consisting of equal rupee investments in stocks A, B, and C and D should provide an expected return of 11.5% and an expected risk, that is standard deviation of the return, of 2.25%. Do you agree or disagree? Why?
So basically, are you okay with these numbers? Now remember, you're going to put equal money in all the 4 stocks, right? Suppose you have, let us say, 1 rupee. You're going to invest at 25 paise in A, 25 paise in B, 25 paise in C, and 25 paise in D. 0.25 the proportion, right? If that is the case, is the expected return 11.5% and also the portfolio standard deviation, how much given? What is the number given?
2.25%.
Oh, okay. Now you have been asked to check those numbers, right?
Yes.
Next, second.
Second question, suppose a market is expected to have a return over a forward period of 12%.
Basically, the return on the market portfolio expected for the next year going forward is 12%.
With a return variance of 6% square.
6% square.
Calculate the expected return and risk for a portfolio consisting of equal proportions of stocks A and B.
And here you have been asked to find the portfolio return. They could have mentioned this particular question is based on the Sharpe, the single index model. They should have specified. Is that fine?
Yes.
The first one they specified Markowitz, right?
Yeah.
And the second should have been what? Based on the Sharpe, William Sharpe, SHARPE, right? Sharpe single index model. Now let us go ahead and calculate first part. Let's answer the first subdivision. Now, how do you find the expected return on the portfolio? They're given the forecast return for the 4 stocks, right? Either you can do the return into 0.25 each and then sum it up. Or what you can do? You can add up the 4 rates of return given divided by 4. It's as good as each rate of return into 0.25. Is that fine?
Yes.
That's a no-brainer. And then next, you have been asked to find the portfolio variance or the portfolio risk under Markowitz. Now we have to use that long equation, right? But here there are 4 stocks. So refer to the calculation. First, what I will do, I'll first calculate the covariance between AB and then AC and then BC, AD, all the combinations, right? Now just see, using the information regarding the correlation and the standard deviation which I can calculate for the stocks, I can find the covariance. For example, let us start with
AB.
RAB. I'm going to use that correlation AB, that is RAB equals covariance AB divided by sigma A into sigma B. For example, what is the correlation given? 0.4, right?
Yeah.
Equals covariance I don't know, but we have to find the sigma A and sigma B. But sigma A is not given directly. Now refer to the question. They given the systematic risk how much?
5.
As 5. And unsystematic how much?
4.
4. Add both. 9 is the total variance of the stock. And what is the square root of that?
3.
It is 3%. So that is supposed to be sigma A. And do the same thing for B. Is going to be square root of?
2 plus 6.
Exactly. Square root of 8.
8. 2.828.
Exactly. Now you just have to do a simple math, multiply, your calculator will do the rest, okay? Now how much you get covariance?
3.394.
Do that for R, then you take R, AC and find the covariance AC. How much you get?
So we got 4.2 covariance.
4.2 as covariance. And then find R,
Or BC.
BC.
We
So
got
can we do
3.394.
AD? It doesn't matter, right?
Any
Any
order
order
is
you can
fine.
do. So R, BC done, and then R,
BD is
BD.
3.162.
and then R,
RAD is 1.342.
and finally RCD.
Yeah,
Right.
4.025.
Now after you find all these numbers, but do remember, if you want to find the standard deviation for the stocks, please add up the systematic and unsystematic risk. That is basically which is a market driven risk and stock specific risk, right? Unsystematic. Add both, that is the total variance, and you take the square root for that number, you get the standard deviation. Okay, once you have the covariance, then you use a long equation. Okay, refer to the formula. Now portfolio variance equals Markowitz formula. It is the proportion invested 0.25 needs stock. So 0.25, how's a 0.25?
1 by 4.
There are 4 stocks equally weighted, so 1 by 4, right? So 0.25 into 0.25 weight is square. That into variance of A, which is nothing but adding both 5 and 4, so 9. That's it. Don't square it, okay? It's variance already. Plus 0.25 into 0.25 into 8. And that is for B. And 0.25 into 0.25 into 4. That's for C. And then for D, 0.25, 0.25 into 5. Then plus, now we try all the combinations. I'm going to take first 2 times AB, right? Therefore, 2 into the weightage in A, 0.25, into B again 0.25 weightage. That into covariance AB, which is
3.394.
exactly. Then do that for plus 2 times. I'm going to take up A and C. Again, the weights are same, 0.25 each. If it differs, be careful, okay? 2 into 0.25 into 0.25 into covariance is 4.2 between A and C. Then plus, I am going to take 2 times BD, right?
Yes, sir.
So 2 into 0.25 into 0.25, again same weightage, right? 0.25, 0.25 into covariance.
3.394.
And do that for 2 times again 0.25 into 0.25 into.
For BD, 3.162.
And then do that for.
AC and AD.
That's it. Add up all the numbers. Add up
So
all
we
the
are
numbers.
getting 4.06.
And for this, suppose you find the square root, you'll get the portfolio standard deviation. How much you get?
2.016.
That means the answer given out there as portfolio risk for Markowitz is not right. I think they're given 2.25.
Yeah.
The right answer is 2.016.
016.
You know what they must have done? they must have simply taken the standard deviation for the 4 stocks into the weights. Is that fine?
Yes, sir.
Is that fine? They must have done that. That's a mistake. Let's check it out now. Can we do that, Renuka, quickly?
Yes, sir.
Now, what is a standard deviation for A? I think we got 3.
Yes, sir.
Okay, 3. Add up all the numbers. 3 plus, what is sigma B? I think we got 2 point. It's all there in the correlation, in the covariance calculation. It's all there. It is 3 plus
828
exactly plus,
plus,
I think it's 2%, right?
yeah, 4. So
Plus 2
plus,
and then plus,
yeah.
what is standard deviation for D?
Yeah, I'm taking so D
Which is
2.236.
exactly. Add up all the 4 numbers
Wow,
divided
10.0.
divided by 4.
So we get 2.51.
Exactly. 2 point.
51.
Adding up all the 4.
Yes, sir.
Okay, add all the 4 by 4. But what is the answer then? 2 point?
The question is it?
2.25 is it or 5.1?
No, they've given it's 2.25.
Okay, fine. No problem.
One
Anyway, yes, ma? Now, guys, please refer to the printed solution. They had done that as well. That is 52%. So, remember one thing, that is not the way you find the standard deviation of portfolio, because I got to consider not only the weighted deviation and also how these stocks co-relate or co-vary. Is that fine?
Yes, sir.
So, therefore, this is the right way to find the standard deviation. How much you got?
2.016.
And that is the right answer. Is that clear?
Yes.
So, now I shall move on to the second part. What is that? Using the Sharpe single index model. Now, remember this formula. You would have done this. There are sums, where you learn something called the characteristic line. This is a formula where the return on a stock on a security equals, okay?
Yes, sir.
It is alpha plus beta into Rm. That means, in case you want to proceed further with subdivision 2, you are supposed to calculate the beta. Got it? And here you're going to construct a portfolio in the second part using only 2 stocks.
Yes.
Stock A and stock C. Just see the formula. Let's find the beta for stock A equals, it is sigma A upon sigma M
Market
into the correlation between A and M. And sigma A, we know is 3%, right? Root of 9 divided by sigma M is root of 6.
2.4.
And that 6% is given as a part of second subdivision, okay? In the question itself. So, the market variance is 6% square. So, root of 6 into 0.74. And I get the beta. How much?
0.91 is the beta for
0.91. And do that for C as well. How much you get?
0.71.
Very good. Now, you are supposed to apply the formula. The return on stock on the Sharpe single index model is equal to whatever the alpha value given, that alpha, and then plus, okay, the beta into Rm. For A, I think the alpha is given as negative something, right? Minus
0.06.
Okay, plus it is a beta, what you got? 0.91. That into Rm expected is 12% going forward. Now, when I do this, how much I get return?
10.86%.
And do that for stock C as well. And then, since you have been asked to find the portfolio return, where you're going to put equal funds in the 2 stocks, that means what? 50 paise each, right? What are you going to do? Either add both the numbers by 2 or 0.5 into 10 point something plus again 0.5 into
8.52.
That's it. Okay, when I say something, that means I'm not sure about the last, okay, the numbers after the decimal, right? Anyway, so how much you get?
9.69.
Very good. Yeah. Now we shall go ahead and take on the portfolio risk using the Sharpe's formula, which is nothing but, just see the formula. We know portfolio variance under Sharpe formula is systematic risk of the portfolio plus unsystematic risk of the portfolio, right?
Yes.
Now, how do you find the systematic risk of the portfolio? Take the portfolio beta square that into variance of market. We know the beta of the two stocks, right? A and C, and equally weighted.
Yeah.
Either into 0.91 into 0.5 and 0.71 into 0.5, or add both
By 2.
divided by 2, it's all the same.
81.
Okay, so 0.81 square into, we know the market variance is 6, right?
Yes.
How much is it? 3.
937.
That is the portfolio systematic risk. Now let's find the portfolio unsystematic risk. What I will do, I'll take the weightage 0.5. I'll square it because I'm going to into the variance. What is variance?
4.
It is standard deviation square, okay? Therefore, 0.5 into 0.5, the weight is squared. That into 4, right? Variance of A plus, it is 0.5 into 0.5 weight in C. That into, it is 1, I suppose, right? And when I do this, I get 1.25. Then add both the numbers, the 3.93 something and 1.25. In all,
5.187.
And that is supposed to be the portfolio variance. And what is the square root of this number? 2.28. And that is a portfolio risk using the Sharpe's single index model. Is that fine?
Yes, sir.
Using the Sharpe's model, or Sharpe's formula for standard deviation, it is 2 point how much?
28%.
That is all, guys. So guys, please go ahead and jot down the solution in your notebook.